Okay, let's continue on with our exploration. We're going to graph x is equal to 2 cosine t and y is equal to 2 sine t. And first we're going to do it over the interval from 0 to pi over 2. And you can see when we do that, right here is the graph, and we get kind of a quarter of our circle there. Next, we're going to change our t interval. We're going to keep that same function. We're going to still do x is 2 cosine of t and y is 2 sine of t. But now we're going to change the length of our interval to be 0 to pi. And when you do that, that's what you're going to see. You're going to see the semicircle. Next, we're going to change our t interval. We're going to keep our equations the same. And our t interval now, we're going to go from 0 to 3 pi over 2. And we're now going to get 3/4 of our circle. Next, we're going to do a t interval of 2 pi to 4 pi, and we go from 2 pi to 4 pi, we get the entire circle. And then lastly, we're going to graph from 0 to 4 pi, and you see we get the same exact thing as what we did in from 2 pi to 4 pi. So what essentially has happened is this has simply traced the circle again. So the first one, although you can't tell any difference in the graph, the first one only makes one copy of the circle. The second one actually copies that circle twice. So again, the question is to describe the role of the length of the parametric interval. Well, the length of our parametric interval determines how much of the circle is traced. So when we only go from 0 to pi over 2, we only get a quarter of our circle. And 0 to pi, we only get half of our circle. And 0 to 3 pi over 2, we got 3/4 of the circle. And from 2 pi to 4 pi, we got the whole circle. And 0 to 4 pi, we got the whole circle actually twice. And I want you to stop and think about that for a minute. So from 0 to pi over 2 is 1/4 of the circle. Well, we're talking about cosine and sine functions. And this has to do with the period. The period of a cosine or a sine function is 2 pi. So this first parametric interval here only goes from 0 to pi over 2. So this is 1/4 of the period of sine or cosine. Therefore, we only get 1/4 of the circle. So there you can see how the length of the t interval has to not only do with the portion of the circle we get, but also comes from the portion of the period of the sine and the cosine functions. Okay, one more. Part 3. Now we're going to graph x is equal to 3 cosine of t and 3 sine of t. So this would be giving us a circle of radius 3. And we're going to change up our t interval a little bit here. We're going to go from pi over 2 to 3 pi over 2. So before I show you what the graph looks like, pi over 2 to 3 pi over 2, that is an interval of how long? That's an interval of pi. From pi over 2 to 3 pi over 2, that's an interval of pi. So we should be seeing half a circle, which we do, but it's sort of a different half. It's now this side. It's the left half of the circle. We're going to graph that same function, but with a t interval of pi to 2 pi. So again, we should expect half of a circle because our length of our interval is only pi. So there's the half of the circle, but now it's the bottom half. And let's see, from pi to 5 pi, that's a t interval length of 4 pi. So we should get the entire circle twice, which we can't really see on the graph, but we know it would be tracing it twice. And then lastly, from 3 pi over 2 to 3 pi, that's a t interval of 3 pi over 2. So that's going to give us 3/4 of that circle. So the question says, describe the role of the length of the parametric interval. So again, as it was in parts 1 and 2, the role of the length of the parametric interval, it does dictate how much of the circle we get, but the starting points, or the initial and the terminal points, are going to change depending on where that t interval, that parametric interval is. And instead of going just from 0 to 2 pi and having it always start at the same place, when we shift that t interval around, we see the circle starting and ending at different places, like right here and right here. We can see that we had different initial and terminal points. Even though these each gave us half of a circle, they gave us a different half. So the length of the parametric interval, of course, it determines how much of the circle we get, but it also tells us a little bit about the initial and the terminal points, where that graph is going to start and end. Okay, part 4. We're going to graph x equals 2 times the cosine, or 2 cosine of negative t, and y is 2 sine of negative t over each parametric interval, and trace the graph and indicate the direction as it increases. So before we graph these, let's think about them. 2 cosine of negative t and 2 sine of t. Well, the first thing we should be expecting is that our circle has radius 2, because those are our coefficients of our cosine and our sine. Next thing, we have this negative t. Instead of t, it's negative t. So what perhaps you might be thinking is it's going to trace our circle backwards from what it normally does, and that is exactly what's going to happen. So in these directions, it says trace the graph and indicate the direction as t increases. So from 0 to 2 pi, we're going to expect that we get the entire circle, because that's a complete period for sine and for cosine. So we're expecting a complete circle of radius 2. And even as you graph it, our calculator makes the graph so quickly we can't actually see the direction that it's graphing in. But what we can do is we can trace our graph. So I'm actually going to pop the graph up and show you that. So let's get my Inspire up here. And alright, I want to change that just a little bit. So I'm going to hit tab and arrow up, and we were doing 2 cosine of negative t. So I just want to scoot a negative sign right in front of my t values and hit enter. Okay, so the circle looks exactly the same like we expected it to. However, what we're going to do is we are going to trace our graph, and I'm going to move my graph guy around here. I'm looking for t to equal 0. I'm at 5.8, I'm at 6, I'm at 6.1, 6.2. Ha, here we go. T is equal to 0 right here. You can see t is equal to 0. So here's my starting point. Whoops, I didn't really mean to do that. Go back. Oh, it's not cooperating for me. Let me see if I can get it back here with my little mouse arrow. Nope, doesn't want to. Okay, well, t started at 0 up here. Oh, there we go. And as I arrow around, we can see our circle this time, instead of being traced counterclockwise, is going clockwise. So when they ask you to trace the direction of the curve, you want to start by finding that initial point when t is equal to 0. And that's where you're going to start your arrow, and then your arrow is just simply going to follow the direction around your curve. So you can see here that here is our circle, and the arrow, I started where our initial point was, and I included my arrow going this way. So that's what our arrow is going to tell us. It's going to tell us where the initial point was and what direction our graph is being traced. Okay, so we're going to graph that same function for now between pi and 3 pi. So this has an interval length of 2 pi, so we should get our whole circle back of radius 2. And let's see, direction. Well, if you were to graph that and put your tracer on it, this time you would see our initial point would start over here, and we would be tracing again clockwise. So that's how you're going to put your arrow on. You're going to start your arrow here and then just move it around to indicate that we're moving clockwise. All right, and our last one here, our t interval of pi over 2 to 3 pi over 2. Half of a circle, because our interval length is only pi, half of the period of sine and cosine. And then our direction, if we were to trace, you would see here is, oops, early click, here is where our initial point would be, and our direction is going this way, it's going clockwise. Okay, so that is going to finish up Exploration 1 from page 31. There's an Exploration 2 on page 32, which is going to follow very much the same steps that we just did with the circles, but instead it's going to be ellipses. So I would like you to complete that as part of your homework, but I would like you to put it in your notebook with your notes as opposed to in your homework notebook. So on page 32 of your book, Exploration 2, the parametrizing ellipses, that's going to go right here in your notebook, but as part of your homework.